Do shoppers at the mall spend more money on average the day after Thanksgiving compared to the day after Christmas? Interesting question. So, what do you think? Do shoppers spend more money the day after Thanksgiving? What we call that? We call that Black Friday, right? Or the day after Christmas? Do people really care about this kind of question? Yeah, the marketers care a ton. Businesses, they want to know when people spend their money because they want to know when to, put their sales out and expect customers and set up their stores and when their profits are going to go up and down. And yeah, marketers care about data a lot. So how do they go about gathering and figuring out these questions? Well, they do little statistical studies. Here we go. The 60 randomly surveyed shoppers on the day after Thanksgiving spent an average of $124. Their standard deviation was 27 bucks. The 60 randomly surveyed shoppers on the day after Christmas spent an average of 115, a little bit less than the day after Thanksgiving. Their standard deviation was 43. What can be concluded at the alpha 0.05 level of significance? Okay. So first off, the first question is, for this study, we should use, you can see the answer there, a t-test for the difference between two independent population means. How do we know that? Let me show you the notes. See, here's the unit for notes. And it says right here. So first off, did you notice we are talking about averages, means? Where did it say that here? Average. More money on average. The average. The average. So there's talking average a lot, and there's certainly two groups, right? Thanksgiving and Christmas. The average amount of money spent on Thanksgiving and the average amount of money compared to Christmas, right? Two groups, Thanksgiving, Christmas, averages. So we come down here and go, okay, so it's not two proportions. It's not two percentages, it's two means. Means are averages, aren't they? So I'll just write the word averages here. Averages, means, same thing. So it's that. Okay, now you might say, well, how do we know it's not two dependent samples with data? Well, there's not data, right? We don't have any data here. So we're on this one, two independent means. So on the online calc, so it says right here, the two groups are not matched in pairs, they are independent. Yep. Well, I'll explain that more later, another problem. For the online calculator, go to two independent samples with data for a list of data, or with statistics if there's no list of data. Now in ours, there's no data list. So here, that's another problem. So see right here, there's no list. There's not like a box with a bunch of, in fact, I'll show you this other problem where there is, like I just showed right there. That's data. This is a different problem. That's data. That's what we mean by a list of data. We don't have that here. So on our question about the mall, shopping at the mall, Thanksgiving and Christmas, there's no data. Notice that. Oops. So no data. No data anywhere. So again, back to the calculator. We are going to grab the two independent samples with data. No, not that one. Or with statistics. No list of data. So two independent samples with statistics. That's where we're going. So two independent samples. With statistics. Two independent with statistics. Two independent, I should have snuck in the word samples. Two independent samples with statistics. That's what we have here. We're going to go to that on the calculator. And so this is two independent means. How did we know we would choose that? It's t-test, but how we came to it is there's two groups and their means, averages, right? Let's do that right there. So it just says, so it says average. Mean is average. So two independent means. All right. The dependent is something else. We'll get to that. All right, so let's go to it. Where is it on the online calculator? Whoops, I'm in the wrong spot here. There it is. Okay, so where are the two independent means with statistics? Two independent samples with statistics is number 18. So you have 18 right there. Two independent samples with statistics. 18. And there we go on number 18. So first sample, second sample, sample size, sample mean, sample standard deviation. First, second, size, mean, standard. So let's go back, write all that down. So we're going to have, so size, mean, and standard deviation. And we're going to have the first sample, second sample. Okay, so what are our numbers? Well, for the, and what is the first second? Well, first one is Thanksgiving. Right, this is Thanksgiving, the second one is Christmas. Well, why? Because that's the order they came in the word problems. It's just whatever order they come in the word problem. It said day after Thanksgiving compared to the day after Christmas. So here we go. What's the sample size for Thanksgiving? Well, it says 60 on the day after Thanksgiving. And they average was 124. That's the mean amount of money they spent. Standard deviation was $27. And then now 60 random shoppers after Christmas, same sample size, coincidentally. Average of $115. Standard deviation, 43. So those are the numbers we're going to put in. But we also will need to select. Oh, I forgot to do HO. Yeah, up here, this should be, oops. There we go. This should be mu1, mu2, and equal, right? It's always equal. And this is going to be, H1 is going to be mu1, mu2. It's either going to be greater, less, or not equal. Okay, how am I getting that? Let me go up to the calculator and show you. So again, we're down here. We're on the two independent means, right? The hypothesis is HO mu1 equals mu2. H1, mu1, mu2, greater, less, or not equal. So there it all is. So we're doing the mu's because these are averages. Mu, this is mu, which is a Greek M. Mu. Now I'm saying mu like a cow, moo, mu. Let me write it right above it. This is a mu, which is a Greek M for mean. Just remember mean. So we see mean because these are averages. Means are averages. We use mu. If it was a percentage, we would use P for proportion. Okay. So what are we going to do with this? Well, you know that HO is always equal and H1 is greater, less, or not equal. Now, which one is it? Well, we look for a key word like more, less, greater, higher, lower, smaller. Do we see any words like that anywhere up here in the original problem? More right there, more money. Do shoppers at the mall spend more money on average day after Thanksgiving compared to the day after Christmas? So more. So that's going to be greater. Right? So we're wondering, you know, our first group is, it says right here, is Thanksgiving, this is Christmas. So we're saying, is Thanksgiving more than Christmas? That's what they're asking us. Do shoppers spend more day after Thanksgiving compared to the day after Christmas? Thanksgiving greater than Christmas. That's the question. Or is it equal, right? We have the two attorneys, HO and H1. They're arguing. HO is saying these two averages are equal. The other attorney is saying, no, 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 no. The first Thanksgiving is greater than Christmas. And then this would say, no, Thanksgiving and Christmas are equal. This one's saying Thanksgiving is greater than Christmas. Who's right? Well, we take the data, throw it in the calculator, but first we've got to get the radio button. Radio button. And that's going to be greater. We get that right there from H1. Is that all we need? Let's go look at the thing to help us here. For our button says choose radio button dot matching H1. There we go. So let's do it. Let's go back, put those numbers in. And then the last two, I don't remember. What are they? So 115.43. I already put those two in. 115.43. Okay, and the radio button Got to choose. You see the radio buttons over here? You're gonna choose greater, and that's it. Calculate. And what I care about is the T and the P. See the T and the P right there. So there's the numbers I put in. Hit calculate. Looks like P is 0.086. Let's go see if that's right. 0.0864. Yep, that's right. So there's the T value. There's the P value. We got those correct. We're putting those numbers in. Now it's time to draw a conclusion. How do we do that? Well, you know the deal, right? We take the P value and we compare it to the alpha level. That's always the game plan. P value compared to alpha level. What is our P value right there? It is 0.0864. What's the alpha level? Oh, right there. Alpha 0.05. Okay, which one of those is bigger? 0.08. 0.08 is bigger than 0.05, right? So you remember the saying, if the P is low, then the HO, this is the thing we memorize to finish any hypothesis test. If the P is low, the null must go, meaning go away. So if the P is low, the null must go away. Is our P low? Is our P value low? No, the P value is greater. It's not low, it's greater. So we're going to write not low. So if the P is not low, then the HO must not go away. Put knots on those, right? If the P is low, the null must go away. If the P is not low, the null must not go away. So that tells us the null is not going to go away, not going to go away. So that means HO, we're going to fail to reject it. It's not going to go away, meaning we're going to keep it. We're going to keep HO. So that's why we say fail to reject the null. It's because it's greater here. We're going to keep HO. Now, a lot of people ask me, Mr. I don't know how to do these last two. Well, that comes from either HO or H1. And in our case, HO. Because right here, we're keeping HO. So then you just go up and say, okay, what is HO? Oh, and I forgot to write. We always put next to HO weak evidence. And we always put next to H1 strong evidence. Every hypothesis test, no exception. HO is always weak evidence. H1 is always strong evidence. Why is that? It's just like a court of law. When HO comes first because zero's before one. So court of law, what do you do when a criminal case person walks in? You assume the law is you have to assume they're innocent. So we assume HO, and if evidence is weak, if there's no good evidence, then you let them go. If evidence is weak, you stick with HO, you stick with innocence. Whereas if evidence is strong, then you convict, right? Just like court of law. So HO is always weak, H1 is always strong. So what are we doing? We are keeping HOs. You just got to figure out which one you're keeping and just go right on back and come back up here. And we're going up to HO here. This one. That's the one. We're keeping HO, right? So what does HO say? Weak evidence. And mu1 equals mu2. See it right here? Mu1 equals mu2, weak evidence. How do we know that? Because we're keeping HO. It all came from this p-value. Right? Because again, remember the saying, if the P is low, the null must go. So if the P is not low, the null must not go away. We're failing to reject the null. It's not going away. We're keeping the null. Go back to the null and keep it. What does the null say? Weak evidence, mu1 equals mu2. So that's our conclusion. Evidence is weak and mu1 equals mu2. And we see that weak evidence and equal to. Meaning we believe Thanksgiving, and what are mu1, mu2? Remember up here, first one was Thanksgiving, second was Christmas. So we're saying based on our evidence, Thanksgiving is pretty much equal to Christmas. Pretty much equal. Even though they didn't come out exactly equal, right? The Thanksgiving made 124 bucks on average. Average person spent 115 on Christmas. Yeah, but that's pretty close. We really think that that's weak evidence. That's not a strong evidence that they're really different. We think, no, they're about the same. They're equal. That's our conclusion. It's equal to the average amount of money spent. And so there we go.